Our project is special purpose electrical machines for checking the wobbling in sprocket, done by E. Arun Kumar and Raja Sivashakti from Well High-Tech Engineering College students. So this is abstract. What is abstract? It means this project is about the wobbling in sprocket and the causes for the wobbling and machine to check the wobbling of sprocket. If it is a problem is acquired in the sprocket, we should reduce the problem. How can reduce the problem? With the help of special purpose electrical machines. This is the abstract. And the introduction. There are two stations we are using this method. First one is checking process. First one is station is assembly and another one is checking process. What is the existing process? Station 1. In sprocket assembly, adapter and sprocket is together by screwing. While screwing, sequence adder must be followed. If it is sequence adder followed, means there is no problem will occur in 99% in station 1. But we are not following the sequence adder, means problem will occur definitely. There may be a chance of human error. In station 2, wobbling checking is done by dial indicator and ego. But we are introducing this method. It is very easy compared than dial indicator method. So wobbling is nothing but an unsteady rotation. Nowadays wobbling is checked out by a dial indicator. So problem arises. The effect due to this wobbling, wheel linear motion and noise pollution, and then roller chain may jump out the sprocket. So this is a root causes analysis. How we done this method? We have to find analysis how to done this method. Means we can find the 5 solutions where this problem is acquired. That time man, material, method, machines and so the problem is there are 4 M's: man, material, method, machines. Among this process we can use method. The problem is acquired when we found that the problem is in method and in bearing thrust. So objective, our aim to avoid the wobbling and produce an effective sprocket assemble. So proposed system, these are the components we are using: displacement sensor and proximity sensor, electromechanical, pneumatic cylinder, solenoid valve. This is a displacement sensor. Displacement sensor is nothing but used to measure the displacement of moving mechanical parts. If I am tightening the screws, so the screw is metal pressure goes to the displacement sensor, and signal is converted into goes from PLC. The PLC consumes the signals from displacement sensor. So there are 2 kinds of displacement sensors here. So linear displacement sensor and angular displacement sensor. What is the application? Means displacement sensor is to measure the maximum and minimum deviations value. So inductive proximity sensor, when the current flows through the coil, magnetic field will be generated. When the metal contact with that, field voltage is induced in the metal. So DC motor, you already know that. Pneumatic cylinder, nothing but pneumatic cylinders are mechanical devices which use the power of compressed gas to produce a force in a reciprocating motion. So PLC is nothing. PLC is a digital computer and used automations. We have to give more inputs and we have to receive more outputs. So this is only priority methods we can use the PLC. So this is a station 1. This is a station 1. This is a station 1 method, and this is a station 2 diagram. This is black diagram of station 1 and station 2. Flowchart. Here the process is checking this method. Station 1, I am place the component first. If it is okay, means then it goes press cycle start to button and component is clamped. Then it screws the locate. And n is equal to 1. We have to follow the sequence order. Means first we should we should tighten the screw number 1. Apply locatite and tighten nth screw. Sequence order follow means it goes next level. If it is no, means produce the alarm, and the supervisor only can reset the key. So declamp and remove. If it is clamped, means perfectly, and then we can declamp and remove the component. Cycle 1 is completed, and load the components and test ring component presence. So S means then clamp the component. If it is no, means then again we can start this process. So couple the component with the motor and press cycle to start button. Motor start complete on resolution. Result equal to a maximum minus minimum. So result it should be less than 1 minimum. And then make a punch mark, declamp and reset the cycle. Error alarm and indication. If it is no, means error alarm and indication, we don't punch and then stop. totally stop the program. Result means sequence order is followed by the help of the special purpose electrical machine. In station 2, we can detect the phase turnout by the special electrical machine. In conclusion, with the help of this special electrical machine, wobbling should be avoided in this method is 100%. And future expressions, we can find out the wobbling in disc brake. So, if follow the sequence order means wobbling is fully reduced. If now we are going to see the how it is working. So now I am going to explain the hardware. In station 1, we can't do the hardware. In station 2, we can do the hardware. That's only we did the hardware in station 2. If it is sprocket is rotating, we can't find it is wobbling or not. In this electrical method, we can in this type of special purpose electrical machine, with the help of we can easily find out it is wobbling or not. So what it means, this is a sprocket and this is a DC motor, 12 volt supply and 60 RPM. This is a microcontroller 16F870. This is a display, this is 7 pigments and display and then a current transformer. So this is a LDR, light dependent resistor. If it is sprocket is rotating, wobbling is acquire means I am going to check. So LDR will indicate and means wobbling is acquired. The loudspeaker means alarm will indicate. If it is deviation is correct within the 1 mm means there is no wobbling in this sprocket. There is no problem in this sprocket, and we can we can't find the error. So LDR is important one thing in this project. So distance here 3.486. Distance actually reducing. Here 4.561. It depends on the deviation. Within 1 mm it is correct. Otherwise, if greater than 1 mm means it is it has the error. So this sprocket maximum rate is 2500. So with the help of special electrical purpose the machines we can use and reduce the wobbling, we can get the output of 99% in checking process, and in station 2 we can get the remaining 1% and we can get fully 10% output, and the sprocket is important one thing of bike. So this is our project. We done this Royal Enfield company. Thank you.